Assalamualaikum warahmatullahi wabarakatuh. We are from Group 6 that consists by 5 students, which is Ahmad Nur Salihin, Aidit Mustaqim, Muhammad Syahmi, Muhammad Syafiq Haikal, and Muhammad Faiz Bazli. Our project title is Slope Stability. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Syafiq Haikal, and I will present about introduction. Because of our topic is slope stability. Slope stability is the resistance of a slope surface to sliding or collapse, like an open pit or cut. Slope is defined as a surface with one end or side at a higher elevation than the other. A surface of a soil mass that is sloped and not supported by any other surface is referred to as an earth slope. Based on our research about this topic, this slope failure can be characterized in a variety of ways. But the most helpful use of movement and slope forming material as important criteria, together with velocity and water volume and phase, it contains 16 failure categories which are fall, topple, slide, lateral split, flow, and complex.
Hi, my name is Muhammad Syami and I will talk about the case study.
For the literature review, we have 5 journals as our study, which is starting from the Airwoman. Airwoman's journals is published at year 2015 and is about the comparative study of slope stability analysis using traditional limit algorithm method and the finite element method. This is about the studies compared to the study of slope stability analysis using traditional and finite element approach. FEM, which known as the finite element method, eliminate the need for trial and error computation to determine the critical slip surface. The value obtained by using the finite element approach are extremely similar to those obtained by utilizing the limit algorithm method. The second one is from the J. Michael Junkin, which the journal is about the soil slope stability analysis, which can divide into two categories. Which is the first one is the limit algorithm method are commonly used to assess the slope stability, and the second one is the finite element method, which is widely used to analyze the slope motion and understanding the stress strain behavior of the soil, as well as knowledge regarding the soil strength is required for this day. The third one is from the Danish Kazmi, which is the journal is published at year 2017, and this is about the slope remediation technique and overview of the landslide risk management. This is the journal is about the geometrical drainage and returning structure method are all the example of the slope rehabilitation measures. The advantage of using a risk-based strategy is that it detects and assesses the vulnerability to slope. This allows for the selection and appropriate mitigation strategies and a reduction in the possibility of failure. The fourth one is from the Carroll Matthew, which published at year 2014 and is about the slope stability analysis, limit equilibrium or the finite element method. This is have a question which is the as the computers become more advanced, so should we be looking for the more advanced method to analyze the slope stability? Yes, because the adopting a more detailed finite element analysis can yield the significant benefit. The traditional limit algorithm method remain able to produce accurate and reliable result, which mean both have their advantage and disadvantage with the choice of the method used. Last but not least, which from the Behzad Kalantari, which published at year 2011, which is about the comparative study of slope stability analysis using traditional limit. From it's about the review of current method for slope stability evaluation. It's about the slope stability is one of the civil engineering most essential and complex issue, which is the alternative way for measuring a slope safety and have been developed. Numerical analysis method give reason approximation to the governing equation of the mechanic of slope stability.
Reinforced retaining wall. Increasing soil tensile tension builds a reinforced retaining wall's backside. Reinforced retaining walls are self-weighted and resist ground pressure. Sliding, overturning, and bearing forces will be addressed before construction. Type of retaining wall that will be discussed is gabion, cantilever, anchored, and pile. First is gabion walls. Gabion wall is made of a rectangular wire mesh box wall filled with rock or any suitable material. It is used for erosion management, slope stabilization, and slope collapse prevention. Next is cantilever retaining wall. Cantilever retaining wall is a wall that consists stem and base slab. The wall can be made from either concrete, precast concrete, or pre-stressed concrete to strengthen the wall. Cantilever is most often used as it cheap and economical because it uses less concrete. Next is anchored retaining wall. Anchored retaining wall is a wall that uses tie-back system where cable or wire are buried before being anchored with concrete. Steel bars are drilled into the soil to strengthen the soil, minimize ground pressure and slippage. This kind of wall is suitable for loose soil on rocks. Next, MSC retaining wall, which stands for Mechanically Stabilized Earth Wall. The wall is supported by granular and reinforced by panel, concrete block and temporary earth retaining wall. This wall able to handle tremendous weights and height. Other than that, open panel joints and granular backfill makes the wall free draining. Moreover, the wall alignment is stunning once it's done. Lastly, pile retaining wall. This retaining wall is a form of embedded retaining wall used to retain dirt behind the wall to lower the ground level in front. It can stabilize slopes, support excavation, and hold cohesive or thick granular soil. This wall is the easiest, quickest, and cheapest way to stabilize soil. That's all for me. Thank you.
Hi, my name is Faiz Bajri Berman. Today I will present the application of slope stability. Retaining walls. When anticipate ground elevation exceeds soil angle of repose, it is designed to withstand lateral pressure of the soil to sustain the soil terrain so slippery level on both sides can maintain. There will be enough room at the side to grade the slope to stable form in some instance. Larger retaining wall made of concrete built along edges of property slope to keep soil structure from eroding or collapsing. Building process start with placement of form, which will be filled with concrete. Once concrete has cured the form or removed to show massive concrete retaining wall. Then, mechanically stabilized earth or MSE, a composite construction composed of alternating layers of compacted backfill and soil reinforcing component connected to wall face, combination of friction and tension between the backfill. The primary function to prevent structural backfill from eroding. The main purpose is to stabilize unstable slope and retain soil on steep slope and under crest stresses. Flexible gravity structure capable of carrying a wide range of large loads has been developed. Then, engineer must select the most effective combination of construction material based on the wall design characteristic. Backfill gradation, plasticity, electrochemical properties, and general durability should all be carefully studied to ensure the wall's construction and performance. Each phase type has advantages in terms of aesthetic, durability, building process, and expected setting. Steel or geosynthetic soil reinforcement, often in form of strips or ladders, are widely utilized. This soil reinforcing choice has built-up and tensile capability, corrosion resistance, and durability. As spacing element, modular precast concrete panel or wire mesh are employed. Then, benefit of MSE is to withstand exceptionally heavy load, can withstand seismic and dynamic pressure and distribute bearing pressure over a large area, faster than traditional retaining wall, can modify to any geometry and have a very easy building procedure cause doesn't require any large machinery, free draining to granular backfill and open panel joints, flexibility to withstand large differential settlement and several feet of total settling owing. Lastly, the design of MSE retaining wall. First, facing element. Second, concrete panel. Third, wire mesh panel and basket. Fourth, soil reinforcement. Fifth, high adherence HA rivet reinforcing strip. Six, high adherence ladders. Seven, retain earth to wire ladders. Eight, geostrap geosynthetic reinforcing strip. And lastly, select backfill.
Hi, my name is Saidi Mustaqim and I will continue to present the application of slope stability. So, I will explain the stability for the selected technique in the long term. Retaining wall used to keep soil in place, stabilize slope, and support foundation ditches. Retaining wall common use in construction, transportation, and subsurface. A retaining wall's stability or collapse can be caused by a variety of factors, as example temperature or humidity fluctuation, material degradation, and load variation. On retaining wall, both static and dynamic stability are required to maintain wall stability. Static stability of retaining walls have looked at how parameters wall height, wall width, and wall thickness affect the stability of wall. To save resources, the optimal retaining wall dimensions were suggested. Retaining walls are useful structures that act as a transition between different elevations. The installation of retaining wall allows for the avoidance of steep and appropriate slopes. Okay, now I will talk about the hydrostatic pressure. As it has water collects behind a retaining wall, the lateral pressures pushing on it increase. The more water has gathered behind a retaining wall, the higher the hydrostatic pressure. If the overturning moment exceeds the resisting moment, the wall might be toppled. So, the alternative that we found is we advise that whip holes be drilled through the wall. Whip holes allow water to escape from beneath the wall. Next, the technique to relieve hydrostatic pressure is to install a drainage channel beneath the wall. The pipe could be installed directly above the footing or at a higher elevation. Or, taller walls may necessitate more than one drain pipe to fully relieve the hydrostatic pressure. At least, I will continue the stability for the selected technique in the long term. First, landslide material removal. Unstable landslide material may be partially or completely removed to improve stability. So this method could be used even it is expensive to control the flow of small earth particles on highways. Next, actuating forces are being reduced. A slope is considered to be at its limit of equilibrium when the actuating forces balance the resisting force. First, surface drainage has been repaired on all road sites that have landslide. Next, the drainage beneath the surface has been enhanced. Where it comes to getting rid of excess groundwater, subsurface drainage is the best option. Even it would be expensive, but for landslide it would be worth considering.
As a conclusion, it can conclude that the slope conditions are less stable due to its poor geological structural characteristics such as large topographic area, steep slope, and high discontinuity content. Retaining wall can prevent the landslide by stabilize the soil. So the retaining wall can help protect soil from the kind of movement that can happen because of natural disaster. That's all from our group. Thank you.